common factor out of 2. Our 2x plus 1 to the 4th, we have a 2x plus 1 to the 4th and a 2x plus 1 to the 5th. So we can common factor out a 2x plus 1 to the 4th. And then we have a 3x plus 2 to the 4th and a 3x plus 2 to the cubed. So we can common factor out a 3x plus 2 cubed. So then inside the brackets, what we're going to have left is going to be a 5. That's going to be gone, but we're going to have one of these left over. So 3x plus 2. We're going to add. We're going to have one of these left over. So 2x plus 1. And we're going to multiply that by 6. So, I don't need to add square brackets. So, we're going to keep what's out front the exact same. So 2x plus 1 to the 4th, 3x plus 2 cubed. And then what's inside the square brackets, we are just going to expand. So we're going to have 15x plus 10 plus 12x plus 6. So now we're just going to keep exactly what's out in front, 2x plus 1 to the 4th, 3x plus 2 cubed, and then we're just going to simplify what's inside. So we know we can have 15 and 12 are going to add together for 27x. And then our 10 and our 6 are going to add together for 16. So now that we have that, we have our y primed. So now if we look back up to the original question, we are supposed to find the value of dy by dx for the given value of x. Our given value of x was x equals -1. So now all we're going to do is we're going to take that y primed when x equals -1. And we're going to sub in -1s for all of our x values. So 2 to sub in our -1 for our x plus 1, all to the 4th. 3 sub in a -1 for our x plus 2 cubed, square brackets, 27, sub in a -1 for x there, plus 16. Then all we're going to do is multiply this out. And the answer we are going to get is 22. So when y primed at x equals a -1, it equals 22. So to make a therefore statement, so therefore the value of dy by dx when x equals -1 is 22. And that is the end of example number 3. Okay, so I'm just going to give another close-up of the example number 3 with all the writing, just in case you couldn't read it due to the blurriness. So that is the end of example number 3. So there are 3 things I came up with that we should always remember about the product rule. So the first thing is that you almost always use the product rule if you have 2 distinct functions. If you have your 2 distinct functions, not only do you always use it, or almost always use it, but it is also the easiest way to figure out, to derive, or to figure out when you just use the product rule. So the second thing is to remember the formula, which is derivative of the first function times the second function plus the first function times the derivative of the second function. And the third thing to remember is that you can use it in conjunction with the power of a function rule. So don't forget that. Don't see 2 functions and think that you can't use the product rule because one of them is to the power, or both of them are to the powers, since we did work out problems where they were both to the powers. So our final thing is to check your learning. So when would you not use the product rule? So A, would you not use